So we talked a little bit about liquids. Now I want to get into the nature of solids. And so the first thing is that we need to recognize what makes up a solid, or the fact that a solid is because mostly temperature and of course intermolecular forces and whatnot. But if the temperature is below the melting point, then the substance is a solid, and that could be a very wide range of temperatures, but that's basically the idea. Nature of solids. We first have crystalline solids. Crystalline solids are made up of crystals. They are regular repeating patterns. They're made up of unit cells. There are 7 unit cells. I'm going to show you what they are real quickly. They are this. I like this little diagram. So notice here that we have a cubic type of arrangement. And let me mention about a cubic. Okay, a cubic unit cell, the lengths of the sides, and you can kind of see here, if I put like A, this says B equals A, so B and C, and it says A, B, C. But basically, if the length, width, and heights are A equals B equals C. They're all the same size. And if I say angles, and in here they're using alpha, beta, and gamma. If you don't mind, I'm going to use X, Y, and Z. But basically, all our angles, X, Y, oops, let me just, rather than equal, X, Y, and Z are all 90 degrees. That's a cube. Okay, I won't take as much time with the other ones, but a cube, X, Y, and Z are all 90, so we've got this nice common arrangement. A tetragonal, or the second type here, tetragonal, is A and B are equal, but C is not. And all the angles are still 90 degrees. So you can see all the angles are 90 degrees. Makes sense just looking at them right here. But notice that A and B are equal, but not C. Okay? And so obviously it's like a cube that's a little bit taller. The third type is the orthorhombic. Okay? Orthorhombic. These are the different unit cells. An orthorhombic, A, B, and C are not equal to each other. Okay, they're all the angles are still 90. X, Y, and Z are all still 90 degrees, and you can see it makes sense. Again, they all look, this is nice, 90 degrees. But A, B, and C are not the same. Okay, so you can see in this one where we've got a taller length here, but it is also wider than the base. Okay, the fourth one here is this hexagonal. Oops, spelling. And the hexagonal, 6 sides, and I'm going to just kind of leave it at that. 6 sides. Pretty simple. It's that kind of, you know, if you looked at it from the top, it'd have that 6-membered side, okay? The next 3 are kind of similar, a little bit different, but the next 3 here, a rhombohedral, is where A, B, and C are all equal to each other, but none of the angles are 90. So angles X, Y, and Z are not 90 degrees. So it's kind of like a cube that's been tipped over. A, B, and C, notice that they're all equal to each other, but they're not 90-degree angles. So it's kind of on its own. These next 2 here, monoclinic and triclinic, the last 2. So monoclinic and triclinic I'll talk about together. A monoclinic, again, A, B, and C are not equal to each other. And triclinic, the same thing, not equal to each other. But in a monoclinic, only one is not 90 degrees. So X, and y are equal to 90 degrees, not z. So only one. Whereas in a triclinic, x, angles x, y, and z are not 90 degrees. So hence the tri. All three are not 90, as opposed to a mono, one is not 90. Okay? Notice monoclinic and, triclinic and rhombohedral are kind of similar. The difference being that A, B, and C are equal in a rhombohedral, not equal in a triclinic. These are your 7 unit cells. All crystalline solids are made up of these unit cells. Okay? Now there is a little arrangement. We have face-centered and body-centered and all that stuff, but for our basic primitive unit cells in crystals, these are the 7. So any solid that's a crystal is going to be made up of one of these 7 unit cells. Let's get on back here. And I want to finish by just quickly talking about the fact that anything that's a unit cell, made up of a unit cell, crystalline solids, they have specific points of melting, freezing, boiling, and condensing. And then again, melting and freezing are opposites, boiling, condensing are opposites. But any of these crystalline solids would have some of these. All right? Let's leave it at that for now.